we'll see how it will be a brief one. Okay, we'll expose ourselves to DICOM and some ways to process medical imaging. Right now, this is not an imaging class. Yes, if I say imaging class, this is not introduction to image processing. Okay, this is just part of the AI. So I'm not going to go deeper into the mathematics and also, yes, the maths and the serious algorithms that are implemented. But what we will do is we will focus mostly on the AI algorithms. Okay. Tomorrow, if we're willing, we will see one of them, the convolutional neural network, and we see how it is implemented so that we can also code it. Okay. If you have a question, you can raise your hand and I'll be able to allow you or unlock you. All right, so these are our learning outcomes. Okay. All right, so what do you know about DICOM? Let me ask the question again. What do you know about DICOM? What do you know about DICOM? We'll type your answer. Okay. What do you know about DICOM? Okay. So let's go. Hey, Beatrice said no idea, please. Hey, you guys, are you not doing DICOM? You've not done that clinicals. DICOM. But you know what a pack is? Hmm? Hey, Beatrice. Beatrice said, I didn't know what a DICOM is. So somebody said it's basically about how images are ordered and shared. Somebody's also giving the full definition. Digital imaging and communication in medicine. Okay. DICOM is a software that allows for storage and post-processing of images. Another person, it deals with the storage of digital files. Full meaning, which is digital imaging and communication in medicine. Yes. Okay. Who else? More, we are 35 here. Only 6 people has responded. I want more response. Okay. The body is strong. So sometimes you get tired, but you still have to do what you are doing. All right, so we have okay, it deals with the storage of digital files. Okay, digital imaging and communication in medicine that allow transferring, processing, and storage of information like CT. Okay, that's Anthony. Standard use in sharing. Okay, then it's basically about images. Okay, all right. So yes, most of you, what you said, they are all correct. Okay, so let's dig deeper and find out a lot about this DICOM. Like somebody gave the full definition. So what actually is important Okay, let me even ask another question. How can you differentiate between, all right, so, oh, let's go back, cancel. How will you differentiate a normal image from a medical image? Okay, how can you, okay, what the difference? Okay, let me, so what the difference between a normal image and medical image? So what is the difference between a normal image and a medical image? All right. So let me see. How will you differentiate between this? Once someone to tell me something. Okay, especially the ladies. The ladies tell us more because you guys you like taking pictures. We guys we don't like taking pictures. I have only two pictures. Okay, but the ladies they have a lot of them. So I want more answers from the ladies. Mm. Are you guys answering? Okay. Medical image is in diagnosis, but normal image is for now health related. How will you differentiate between them? What's the difference? The medical images are taken only for diagnostic purpose. So if I have two images over there and I want you to differentiate between this one is a normal, how is the normal different from the medical? How will you know? We boys are safe here. Okay, the format of the image. Okay, Dicom. Anthony, I've seen your message. Is it Victoria? Maybe she has forgotten her password though, because I've added her to the call. So is it Victoria again? Okay, let me refresh. I've added her to the call. I even added her before I started. So all right, so you should try again. Okay, let her try again. Yeah, it's not supposed to be here. Her name is what? Victoria. Victoria. Let me see if I'll be able to see her. Um, I mean, it's Victoria Sappho, right? She's part. If she's called Victoria Sappho, that means she's part. Because I've added her here. She's part of it. All right. Okay, so the medical image you use, no, I don't like it. A normal image has little data and no patient identity, but medical image has patient identity. Okay, medical image is for health purposes, whilst normal image is for normal image deals with physical appearance other than internal body structure. Medical image deal with internal body structure. Okay, medical images can show internal structure, normal images cannot. Thank you. So now if I ask you to differentiate between a normal image and a medical image, the only thing you can tell me, if you tell me, some of what you guys are saying, I will not buy into it. But the last one that I read that is near or close is the technology they use to take the image. All right. So what the guy said, I didn't even read the name. Okay, medical image mostly or most of the time is what internal. It's able to what take internal images instead of what the external. But normal images like our photos or whatever, most of the time is just physical or outward. yes, the outward, but it can't go inside. Okay, so that differentiate or that distinguish between a normal image and what's in a medical image. Once you take your image, yesterday we learned about metadata, right? And we said that even the normal images that we take, you see that the Samsung and also the Apple phones, they're able to store data of that data. I mean, the data of the picture that you took. So it tells you the light intensity, it also tells you the area where you took the picture, it also tells you a lot. Okay. Now, in medical imaging, can we also have a way to be able to store the patient's data with the data, which is the scan that we took? Okay, this is where DICOM comes in. But it's not just storing patient's data with, in addition to the scan that you have taken or you took, but it's also a convention that all medical modalities, which is the equipment, they have to comply or they need to agree in order for us to be able to share files, in order for us to be able to, for two modalities to be able to communicate and share resources and files. This is where DICOM comes in. All right, so I don't know whether TTH, we have some there, but if you guys go for clinicals, you can ask if they have a DICOM system over there. Right, so DICOM, the definition here, and somebody provided the full acronym for that: digital imaging and communication in medicine. So there are two things being combined here: the digital imaging and also the communication in medicine. All right, so it's a standard protocol. We talk about protocol mean rules, okay? That's my guide, the managing and communicating the medical, managing and communicating the medical image information and related data. Okay, so we use it to manage and communicate medical images. Okay, so in terms of sharing, okay, for two modalities to be able to share files, we have to put all of them on this protocol so that communication be able to be possible. It's similar to how uh, our internet works. Before you get on the internet, there are protocols that you need to follow. All our devices, they follow the protocol. I don't know if you heard of the word IP address, Internet Protocol. If you heard of the word TCP, Transmission Control Protocol. You've also heard of the word HTTPS, okay, Hypertext Transfer Protocol Secure. So these are rules that our devices has to follow in order for them to be able to share files on the internet. The same analogy can also be applied in the medical field where DICOM is what we use in such a way that we can share files, we can communicate, okay. And the standard protocol that governs this form of communication, sharing of files, is the DICOM. Okay, so the DICOM files convey images and information to system capable of receiving patient data and images in a DICOM format. So yes, Isa Abdul, you have a question or it's a mistake? Is it a question or a mistake? Isa Abdul, your hand is up. Okay, so if you have a question, let me unmute you, then you can talk. If not, too, you can put your hand down. Then we continue with the lesson. Okay, that is not a question, your hand is down. All right, so a DICOM file consists of the origin, patient's identification, the image itself, and the attribute of the image, such as what pixel. Sometimes also stores, not sometimes, also stores the equipment that was used to take the image. All right, so why DICOM? Why do we need it? One, it enables the interoperability between imaging equipment as well as other devices. Okay, I've explained. Okay, so if you are sharing a file between the different modalities, there's a way we can allow them to communicate, and we need a protocol, a rule to do that. That is where DICOM comes in. So it governs practical digital medicine, such as the image formats, so that when you take a scan on one modality and you send it to another, you shouldn't struggle. You can convert it easily. Conversion should be, quite easy, right? Yes, the image format. Then the network protocol required for transmission. Okay, so when you are sharing a files between two computers, they have to agree. Okay, they have to agree. For example, if I want to send a hi message to Anthony right now, okay, they said the message that I will send will be encrypted. My target is Anthony. My phone and Anthony's phone, they have to agree before I can send a message from my phone to his phone. You get it? So that is why the second point is saying that the network protocol required for transmission, it governs that, so that for you to send an image file from one device or one equipment or one modality to another, okay, they have to agree, and there shouldn't be any rejection or any conflict anywhere. Okay. So the importance of DICOM, why DICOM at all? One, the universal standard of digital images. Okay, so in the imaging department, that's the universal, the standard. Okay, then it also provides excellent image quality. Then it also has full support for numerous image acquisition parameters and different types of data. Okay, because it's a standard, it tries to accumulate other acquisition parameters. Okay, because that is what we are considering like the bigger umbrella. So the smaller ones, they all fall under it. Okay, then we can also use to encode medical data. So you already know it that when you take the scan, the DICOM cannot encode everything about the patient. Okay, everything about the patient. Then, since it's encoding the data of the patient, it can also encode the medical devices that you use. Everything. Okay, we try to encode that one also. So these are some of why DICOM is important. All right, so how DICOM works. Now, DICOM uses a method or an approach or a technique called objects. I don't know, those of you who are into programming, you know object-oriented programming. Object-oriented programming, right? So we call it OPS. Now, we in computer science, we will say that everything that you see is an object. When you take an object, it has what properties and what or attribute. It has properties or attribute. If I ask you to give me some attribute of a human, okay, you'll be able to list a lot, right? If I ask you to give me the properties of human, you'll be able to give. So let's try that. So another poll right now. Just give me one property, one attribute, okay, of humans or a man. Okay. Oh, sorry. So one attribute and one property. So you just write the attribute. I'm just showing you the solution, how you type it, then you type the answer, then the property also, you type the answer. Anthony, I don't know. Eh? The enrollment link you use appear no longer valid. Please contact the course instructor. She's after refreshing, logging and logging again. It's not getting. But I added it. I'm coming. I'll take a screenshot of details so that you see. All right. So, give me provide access for me right now. Victoria Safo. Victoria Safo want to stress me this evening. Where is she? She's here. I've added her. I don't know if it is wrong there. I mean, I don't know. I've added her to the course. Please, you can send it to her. I've added her. So, all right. So, Beatrice said attributes integrity. Hey, Beatrice, this one there. Where do you get it from? Yeah. Please, I said one attribute, one property. So type the attribute. You tell me the property too. You tell me. Let's be quick. Jordan, how can you write attribute for me? You don't understand the question. I'm saying that give one attribute of human. So one attribute, I should use the word property rather. Okay, property is there. So one attribute of human, the one attribute or one property of human also. So if you type attribute, then you type the answer. So attribute colon, type the answer. Then property, you type property colon, you type the answer. That is what I'm referring to. Let's be quick. Your man is, I'm tired, I'm exhausted. Work for me. Yes, who is that? So Anthony, I don't know because some of these students sometimes they are even doing the wrong thing. Okay, I've added her to the course. Find out. I mean, she said she's able to log in, so he's able to log in and said, find out the login detail. I don't know if she has a different login detail. I can't tell. Maybe she might be using a different login details, the one that you did not send to me. Okay. Okay, so here, Benson Richard attribute creativity, only creativity. Then who? Halimatu attribute gender, property, male or female. Hey, you guys, I'm in trouble today. Oh. Okay, Seidu attribute intelligent, property, nose. Okay. Then I have attribute kindness, property, land. Ahmed, please, this one I'm not talking about. I'm not talking about like that property, cars and no, I'm not talking about that. Yes, Beatrice, is it a question or a mistake? All right, so let me try to define things clearly. I mean, so that you guys will understand the concept. Okay. So, for example, when they say the attribute of God, I mean, what are they trying to say? Attribute of God. I mean, that, okay. Then when you say, what are some of the properties of God? It doesn't mean that God is owing a lot of things. No. So, what are the things that man can do? Okay, these are the attributes. Okay, these are the attributes. I can walk, I can jump, I can laugh, I can talk. Okay, so what are some of the properties? What are some of the properties? One, you have a name. Okay, there's a name on you. Okay, you have a height. There's a height. It's a property. Your height is a property, right? Your color skin. All right. So The same scenario is what we use in programming. Okay, we try to model the world as an object where we try to give it properties and also attributes. The same thing we bring it to DICOM where we try to model whatever we do as what as an object. Okay, so when you take the DICOM medical image, it has two parts. We have the header and also have the actual image. We have the header. The header consists or describe the entire image. All right, describe the entire image. Then the actual image is the scan that you will take. Okay, so what are the things that are contained in the header? We have the patient's demographic information, such as patient's name, age, gender, date of birth. Okay, then we also have the image characteristics such as acquisition parameter, pixel intensity. All these things are all included in the header before the image. Okay, so it's like one platform. So part of it we use to store the scan, and part of it we use to I mean store your demographic information and also image characteristics to as well. Beatrice, is there a question or you made a mistake? Because if you have a question, you keep your hand up, I will let you answer. All right. So we said the DICOM models of things, okay, like objects. So because of that, we have when you try to put the properties and all these things together, it becomes the IOD, information object definitions. Okay, sorry, information object definition. So the objects, you're talking about the property, you're talking about the attribute, trying to put everything together. That is how we call it the IODs. Okay. Now, all diagram attributes are formatted according to 27 value representation. Okay. So the attributes we spoke about, okay, anytime we take a DICOM, so we have a DICOM file or a DICOM object, okay, we have 27 value representation that we use to describe it. We'll talk about them, okay, as we progress. All right. So let's look at it. So let's assume this is Anthony. Uh, Maybe Anthony is fine, okay. Then she went to the hospital. So he went to the hospital and they took maybe a scan. And if you look at it, we have we have an information over here. Okay, this is what known as the patient's IOD. All right, so we have the name, the ID, date of birth, all these things. So as I explained earlier on, we try to model everything like an object, which is supposed to have what attribute or what properties. So here, if you look at it, we have certain attributes, we also have certain properties. Okay, the name, the ID, date of birth, weight, sex. Okay, so that is the patient's information object definition. So this describe the patient. All right. We said this DICOM IOD, we use 27 value representation over here, okay, to define it. All right, so how is this thing done? In programming, we call something syntax, okay? In DICOM also, we also have a syntax, that's the grammar. There's a grammar we need to understand, or there's a syntax in DICOM that we need to understand so that we'll be able to write DICOM files or interpret DICOM data once we see one of them. And I have to be honest, one of the quiz you guys will write, you'll definitely see one of them and ask you to either write or to interpret. So take note of that. Okay. So the 27 basic data types, which is known as the value representation, make sure or we use it to encapsulate all the clinical data type. Okay, all the clinical data. We have 27 of them. So when you go to the hospital, you can use this 27 value representation, okay, to encapsulate or collect all your data type. Right. So let's find out. Okay. So how is the value representation represented or written? We said the DICOM has what? A grammar, there's a syntax you have to follow. So how do you read when I present a DICOM files or a DICOM table to you and ask you to read? How will you be able to identify these things? So one, we use abbreviation. So the value representation, we use a two-letter abbreviation for it. Okay, then a definition to represent, to tell you what a thing is. Then we also have a number of characters allowed. Okay, so for example, if you are talking about name, how many lengths? I mean, what number of characters should we use? Okay, should we use here? Here, how many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 characters. So when you're talking about name, okay, I mean this length, how many characters should we use to represent that? It's like you are trying to build database. Those of you who are into database systems, you understand this better. Then okay, so here is the prescribed data length. Okay, then description of what characters are allowed in the data. All right, then also specify your data type. Okay, the data type. All right, so let's see. This is the value representation definition. So we have shorts, which is sh. So that's why here it's trying to tell you we use what? Two-letter. So the full word is what? Short string. Then you have PN, personal name. Now what's the definition? It stores things like telephone, your ID. Okay. Then these are the characters allowed. That means these are characters that you can use, okay, to represent the short string. So uppercase, space characters, underscore. Then what is the maximum, the length of data type that you can put over there? That is 16. Same thing with the name. If you look at the name, personal name, look at the abbreviation PN, and look at how the description, how it is written. Jessica Martin. Okay, so Jessica Martins. So here we use a delimiter here, a caret. This is a caret to separate the first name from the second name. Then we also have the length of characters. Okay, and the characters. Times 64 maximum. That means your name should not be more than 64. Okay. All right. Then we also have the unique identifier. Okay. Then also have dates, your dates. So look at how the date is written. Some of them will pay attention to it, especially look at the date. It's written as the year, followed by the month, followed by the day. So if you look at this, you should be able to read this for me. All right, which is 2005, August 22nd. All right, so what is the maximum? The maximum is 8. If you should count this, 1, 2, 3, 4, 5, 6, 7, 8, until it's through 8. And what are the characters that's supposed to be there? They are all numbers, 0 to 9. You can't put a letter over there. Okay, you can't write August 22nd, 2020. No, that is wrong. Okay. All right, so let's look at just now. I believe some of you will be able to read some of them for me. For example, look at the value presentation, this column that represents the value presentation. You see, now you see PN, you saw PN, right? Which is personal name or the patient's name. Now, if you look at it, we have a tag. Each value presentation is having a specific tag. Okay, so what is the tag? Or like a number that we use. Okay, it's different from your ID. It's different from the ID. It's a tag. It's like a database generated in a DICOM, and they try to use this tag for us to be able to group these attributes and features. Okay, so if you look at it, you see that anything related to the patients is what 001. Sorry, 0010, 00. So we look at this column. Okay, if you look at this, you see that 0010 is everything related to the patient. Okay, then you come to the next one. We try to identify the specific thing that we are talking about, which is the value representation. So here we have 0010, 0010 that talks about the patient name. Then when you come here, 0010, 0020 talking about the patient ID. Okay, the patient ID. Then here here using P, and here using what, LO, I didn't talk about it. Then here using dates, okay, then time, okay. Then we also have sex, that will be the gender. All right, goes all the way. All right, so this is something. Now let's look at the top here. You see the top here, if you look at it, it's different from that. In such a way that if you look at the tag 0008, okay, so that one talks about something different. Okay, we will learn how to read DICOM files when I come, and you should be able to read and interpret your results and write reports based on it. So let's look at how to encode. So here, this is the patient, and that is the name. Okay, so here, everything about the patient, that's why I use the word patient over there. So when we come here, we know the tag for the patient, which is 0010. That is why you see it here trying to tell you that. So that is 0010, 0010, 0010. That means you are talking about the patient rather. Then the next tag try to tell you about the attribute, so the name. Then here it's talking about the gender. Then here it talks about the date. So let's then go and find out. So if you look at the gender, the date is 0030 and the sex is 0040. Let's go and see whether it's like that. Okay, yeah, 0030 is for the date, 0040 is for the gender. Obviously, so now we define our tag. The next thing is how do we write it? We said you separate their names, the first name from the second name using what delimiter. That's why you see a caret over here. Try to separate that. So if I if I am taking it or I'm writing it, then it becomes something like Richard A. Asiamah. Or you can also write Jessica Martin. You can also write who else do we have here? I want a short name. Okay, Isa Alasa. All right, so as you can see, so we try to separate that, okay? Then here, if you want to give it, then you can go ahead to say, okay, I'm giving the tag with 0010, then 0010, okay. That defines that, okay. Oh, all right. Then you can go on, then define the rest, 0010, comma, then whatever you want to put over there. Okay. So you can build, okay, some of these things or write some of these things by looking at it. So that means you need to, you see the way the arrow is going the other way around in such a way that we can write from here to this place. You can also write backwards. So please take note how to move from here to this place and how to move from here also to this place. It's very, very important. Okay. So that is that for DICOM. Any question? Then we will talk about image processing. We're done with the first part. The second part is image processing and analysis. Any question? Anthony, has Victoria been able to join? Okay, Khaled, okay, you have a question? Let me unmute you, then you can talk. You see, guys, we are all suffering. See, the first day you guys misbehave, as I decided to block all of you. Okay, so right now I have to go and search for your name and unmute you. Okay. Coming, where's this guy? Oh, Anthony, why? Please, you guys, you need to help Elle because I don't know what's wrong with this one that she can't join. Seth, please be helping them, okay? Help them, let them, because I don't know. Sometimes they made some simple mistakes and they find it difficult to join. I remember a friend of mine when we were in school. It was not even, he was in the nursing department or whatever, and he deleted his work, her work. He cried the whole night. He deleted it instead of you to do undo to let the work come back. We were just crying that. So sometimes, I mean, all these ladies, we have to go and help them. Yeah, undo no. You mistakenly deleted the work from Microsoft or Word. Instead of you to undo to let the thing come back. She cried the whole night. Sometimes it's funny, our ladies, some of them, not all, but some. All right, so Khalid, you can go ahead and talk if you have a question. I've unmuted you. You can go on and speak. Oh, it's a mistake. Okay, maybe it's a mistake.
Sir,
Okay, then. Yes, go on.
the question I wanted to ask is with the tax, the group elements, the 00100020,
Yes.
are they constants that, yeah, for example, 0020 is for patient ID. Anywhere you go that you see 0020 is for patient ID.
Yes, it's constant.
Okay.
It's constant throughout. Okay, so when you're reading any DICOM file, okay, I mean, you see that it's constant throughout. That is why we said it's a protocol, a standard protocol. So anywhere that you go, it should be the same. So when you see 0010, that means we are talking about a patient. Then the next tag talks about a specific attribute of the patient. Okay.
Thank you, sir.
All right. Any more question? Okay, if no question, then let's move on, which is the second part. Now, tomorrow's session is going to be quite intensive. So, guys, please make sure you rest, okay? Because that one will be digging deeper into deep learning and doing some kind of mathematics all along. So, make sure you rest, okay, and get ready. I'm just hoping you can use the 2 hours tomorrow for that. Okay, so image processing and analysis. Now, why do we have to process images? I think I asked this question yesterday. I did explain. Why do you have to process images? Okay. Why do you have to process images? That's a question, a poll. Why do you have to process images? So why do we have to process images? Type. Okay, so Otis says so that the output can be understood, okay, to enhance image quality, all right, for easier identification and storage, to enhance its quality for easy interpretation, so that it can be diagnostically approved. This guy is serious. Who is that? Ahmed. All right, another person here. In order to enhance it, contract contrast and make it diagonal. Is it contrast or what? Maybe it's contrast rather not contrast. To make them nicer and better looking. Okay. It will enhance the quality of the image to improve its quality, enhance image quality for interpretation, we process image for better visualization, for standardization and reproducibility, and to improve image quality. All right. Okay, so I mean, they are good. Okay, they are good. So let's find out more and what's expected of us. Okay. Now, this is your field. You are always taking scan. Okay. So once you take the scan, you have to give it to is it the radiologist or the neurologist for them to read or interpret the results, right? Now, if the scan that you took, one, yesterday we learned that machine learning and deep learning they able to what? Wow. Okay.
Lectures come on Asiamah.
Guys, I'm coming in.
All lectures.
Okay, so once
No,
you take the
me
scan
too.
and you give it to radiologist or neurologist for them to read, if the scan that you took is not all that clear, remember they are going to struggle, right, in order to interpret the results. And yesterday we learned that machine learning and deep learning able to extract certain features that we human beings will find it difficult to be able to see. All right. But although this machine learning and deep learning are able to do that, we still have to process. And we remember yesterday we saw the difference between machine learning and deep learning. That machine learning, the feature extraction, you have to do it yourself as the programmer. But deep learning is able to extract the features on its own, right? But although deep learning is able to extract the features on its own, but remember, the results or the accuracy of your model depends on the quality of the data set you feed to the model. So that means it's very, very important for you to be able to process your images well before you feed it into your system. And yesterday we saw in some ways that one, you can do augmentation. I say augmentation. Yeah, you can do augmentation, right? Then also, what are some of the things that we spoke about? Augmentation. What again? Augmentation. What else? I'm teaching a lot of people, so we are forgetting. Okay, let's go. Okay, so. All right, so medical imaging have become a widespread since the discovery of what? Of X-ray, right? And hey, I'm in trouble today. So the introduction of computer tomography has led to significant surge in utilization of medical images. But mind you, about 90% of all healthcare data consists of what? Medical imaging. That means a time will come. I mean, most when you go to the hospital, the first thing they will tell you, go and take a scan. And I think it's happening, right? The doctor will just say, go and take a scan, go and take a scan, go and take a scan. Yes, they need a scan more than anything. So if they need a scan more than anything, that means the quality of the image or the scan supposed to be good in such a way that the doctor will be able to interpret the results, okay, or interpret the outcome. That is why we need to process it. And I told the level 3 the same thing. Guys, I won't lie to you. It's a hot cake. Some of these things. If you can, I mean, take it up, some of you, not all, some of you can take this thing up and work because I mean, imaging will replace a lot of things in the near future. Imaging will replace a lot of things because when you go to the first thing, go and take a scan. So those who are able to work their way out around this, I mean, it will be hot cake. Okay. Hot cake, yes. All right. So, what is image processing analysis in medical imaging? It entails the techniques or fundamentals that we use to enhance, clarify, and extract meaningful information from data. So first, we are enhancing. Two, we want to make sure we classify whether this is indeed a tumor or not. But sometimes you find that you struggle. Okay, you the radiologist is actually struggling. Hey, is it a tumor or not a tumor? So we need a better we need a better
But just
processing technique to clarify this and also to extract meaningful information. Yesterday, we saw the feature engineering. I said they will know the difference between feature extraction and feature selection. Feature extraction and feature selection. And I'll ask you a question to make sure that you guys will understand it properly. All right, so what is the pipeline? We keep seeing pipeline. Please make sure some of the pipelines you know them well. Okay, so image processing pipeline. Image processing pipeline. We have one. You need to acquire the image
after weekends. Then
you need to acquire the image. That's the first thing. I mean, you need to acquire the image, right? And the second one is pre-processing. That's what we're going to talk about. But anytime you pre-process your image, the next thing that follows is you segment. Okay, depending on the project. If you don't segment, you need to extract features. Okay, so then you can classify. But mind you, you can put some of them together. Okay, in order to do detection. Remember, I said if you want to detect an object, you first have to localize it. Okay, then you categorize it, right? All right, so you first can segment, put it into what? Different regions. That means if you have your picture, you can put it in logical regions, okay? Or you'll be able to do feature engineering. You extract the features can be the edges. It can be, yes, the edges most of the time. Okay, if you want to know the shape of an object, most of the things, the edges helps you a lot. Okay, then you can also classify whether the thing is tumor or no tumor. Then we have the image post-processing, also interpretation and visualization. We are going to talk about I think these three, okay, these ones, the 6 and the 7, we are not going to visit it. All right, so pre-processing techniques. So pre-processing, there's a word there, I mean, we have to do this one before we even start the processing, right? Right. So pre-processing techniques, I mean, deals with the various methods that prepare the medical image for better interpretation and analysis. Okay, so what are some of these techniques? Let's see. All right, so we have noise reduction and image enhancement. Noise reduction and image enhancement. All right, so when you're reducing noise, as I said, this one is actually not imaging course, okay, where you look at the mathematics and all sort of things. And because this one I'm just attaching to AI, I decided not to go deeper into this. Okay, you want to reduce, there are a lot of noises that you have, speckle noise, salt and pepper. There are different types of noise that you need to find a way to remove. And you guys will, I mean, attest to the fact that when you are taking a scan, some of the noises, that, I mean, you see in your scan comes from the patient, right? So we have patient, when the patient is blinking the eye and all these things, able to generate, is it blinking the eye or moving? Sorry, patient moving. Then also noise also from the device itself, the device, whether it's the CT scan or whatever, they also have got internal noise that they generate. Then enhancement. Now sometimes you want to make sure that you decrease your contrast, you increase the brightness. Okay, I mean, you are trying to enhance it in such a way for some things to be clear at the background. So these are the techniques. So let's look at them. All right. So noise reduction. So here you have two images. Here, if you look here, you see you have noise here, but here it has been smoothing, right? Sometimes they use filtering. You have filters to use. Okay, you have different types of filters. New filter, medium. As I said, this one is not image processing course where we will talk about some of these things and even write code for them. But what we do over here is related to an AI. Okay. Then here also you also see noise and that's also being filtered. Okay, so
the online class, are you catching up?
The noise. That is noise reduction.
No, have you ever joined it like full time?
So all the explanation I gave,
Never.
they are all here. So
Oh God,
noises you
don't
can
worry.
get it from
I'll come and
uh,
give you a copy
where is
a copy
it?
of it.
Okay,
If
so
like
here medical
if you share it,
images, whether from X-ray, MRI, or ultrasound, frequently
I'll
encounter
come and give you a copy
disruptive
of it.
noise,
Have you get
whether
that
from
PM?
inherent equipment limitation or what patient motion. I believe you know it,
Your own is what?
or you guys go for clinicals. So
Is
either
what?
it is the patient or
Huh?
uh,
To do what?
the equipment. Okay. And when you have noise, what
I
actually
forgot. I
happens
forgot by now.
is
Oh, if
obscure
students are about to
whatever
finish school,
information that
that
you are
time then they
looking for.
prepare
They
them with
hide it,
allergies.
so you are not
Oh,
able to
well.
see. Okay. So the noise reduction, it can
Abi, your
eliminate
laptop is there.
disturbances, ensuring that images are clearer and more
Okay, then
precise.
later.
So let's find
When you
out
come back.
what are some of the ways. We are not going to talk about them, but I'm just showing you. You can go and read about them yourself. We have
So how
linear
you join the
filtering,
online
median
class?
filtering, diffusing filtering, gradient adaptive smoothing,
and
bilateral filtering, guided filtering,
this one class.
Bayesian image restoration. These are all
Wait, it do and if you go rewatch them, but some
noise
days time
reduction
disappear.
techniques. Okay. And Legon, the biomedical students, they
record
do
So you mean
image
the
processing.
first day
So that is a course you do a full
it
course.
is.
So
So
we
meaning some
normally
few days
dive
time go
onto the
disappear leave the
mass,
second one.
keep behind all these things and write code, sometimes in Python and MATLAB to do all these things. But this is application or introduction to machine learning
Me, I get
and
the copy, sorry.
AI. So it's not image filtering or image processing thing that I'll dive deeper. So you can go and read. Okay, if you have interest, you can go and
No,
read
no,
about
yesterday,
it.
yesterday.
Okay.
No, no,
To
today,
surprise
today.
you how they're able to
Yesterday I can get
some
them
of
already.
these things. Okay.
I don't even enter. Even
Alright.
today own self, I know
Then
Today,
enhancement. So when you enhance an
they give
image,
out notification for engine.
you are trying to make certain parts
I mean, they've never given
okay,
me.
becomes
give me
clearer
from my email,
so that
sir.
we can see it properly. Sometimes you can increase the brightness, I said, you can reduce the contrast or increase the contrast. Okay, there are a lot of things that you can do in order to enhance
when I
your
hit Papa.
image. All right. So
I
how
don't see
is
in
it
block
done?
I won't believe when I
So,
block those stretches. so
Often when
fast.
you take a scan,
no, in
there are
block
certain
only they
parts
do
that
no.
are actually hidden.
No, I mean in
You
block
trying
that's
to
why.
enhance
No,
it,
no, no,
what you
in
do
block
is that
only
what
they do no.
you can modify what? Contrast,
I
the
swear.
brightness,
That's why I say they do
sharpness.
lectures like that.
That
Tomorrow
was
to
so
So
much
how
in
you
the replace
enhance
them.
an image?
Yeah,
You
tomorrow
can
to
modify the
lectures,
contrast,
there's Sunday
you
to
can
lectures
modify
day.
your brightness or your sharpness.
I swear,
These are
I
ways
talk
that
to
you
man.
use to
I've been
enhance
seeing
your
right
image.
back.
Okay,
Yeah, in block
because
only
one
they say like
is
they'll
trying
give
to
us
hide
something,
certain
but
critical details. So by you enhancing your image, these details become what clearer for you able to see. And some of these things, as I said, I mean, you have to sometimes have the skills because you know that, oh, let me decrease the contrast and I'm able to see. And the more you play with this, I mean, the more you're able to understand some of these things. Okay.
the man, you know they care about this.
All right.
Someone else have been inside with you don't know safe and class they go.
All right. So speckle noise in ultrasound can be removed by noise reduction technique, but you can also use what
Bro.
the image enhancement. Okay, to make sure that structures are easier to detect. Okay, structures are easier
Because
to
in fact,
detect.
very big.
All right. So let's find out some ways.
If I save them, it pass.
So we have contrast
No
enhancement.
small space they take.
Okay, so this one you agreed now. We say because of contrast, you're trying to increase or decrease the contrast. Then resolution. When you talk about resolution, what are we saying?
How we do?
Christian, you can raise your hand and try to explain.
30 minutes more, Balamba.
All right. Oh, the person has. Okay, Musa Hussein. Coming, where is Musa Hussein? I can't find him all. Oh, you don't know if also. Okay. All right. Okay, let me explain my thing. Okay, let me explain my stuff. Okay. So resolution. When you talk about resolution, I mean, uh, let me do this. Okay. You have different image compression techniques, right? From PNG, right? Let me write it so that it become clear. So PNG to JPEG, right? Also have a GIF. They also have what again? You have GIF. You also have what again? TIF, right? Yes. These are mostly used for normal imaging. But when you come to CT scan and MRI scan, they use a better compression algorithm. Okay. They use better compression algorithm. All right. So how do you, I mean, move from one form to another? Now, this PNG JPEG, most of the time they store their image using this number of bits. So 0 bits all the way to 255. That is the maximum they can go, which is 2 raised to the power of 8. Okay. Now, when you take CT scan, then the MRI scan, okay, you can't use 2 raised to the power 8 for them. It's going to truncate a lot of information. So that means they need more pixels, right? So some of them, they go all the way to 2 raised to the power 16. 2 raised to the power 16 is what? That is quite a bigger value, right? Let me use my calculator here. All right. Now, why do we need this? Because one, when you take the human body, if you take the human body, the density, all sort of things, the soft tissues, you can't use 255 resolution for that. Okay, you're going to lose a lot of data. So what we do, we need to increase what the pixel. And mind you, you're increasing the pixel, which is the resolution, you're also going to increase the size of the document or the file. So what do we do? Okay, that is why TTH, they normally ask the patient to bring what pen drive, right? Not because if they don't bring it, they can't keep it on their system. Okay, which is 536, right? That is a lot of things. Okay, so when you have an image of this, and some of them even go more than that. Okay, this one can capture more stuff than this one. Okay, than this one can capture more stuff than this. All right, so when you try to increase the resolution, okay, things become more smooth. As I said, this I'm not teaching you guys image processing, but let me give you guys a demo. So when the resolution is less, okay, you see a grid like this. Okay, I don't know whether you guys have done it, but when you try to enhance the resolution, that means you increase the resolution, you try to close the gap. So it's a smooth transition and things become a little bit clearer. Okay, so when you see most of the time images that are blurred images, remember the resolution is what? It's a little bit low or very low. Or when you see images which you see is very the quality is good, remember that the size of the image is very big because of the increased resolution. All right. So that's for the next one I want to talk about is segmentation. Okay, so you saw the pre-processing, noise reduction, and all image enhancement. These are the pre-processing. So once you pre-process, the next thing is you now want to segment your image. So segmenting, yesterday we defined, is when you have an image and what you try to do is to partition the image according to various distance or into various regions. Okay, regions. So what it normally does, it uses the intensity of the pixel. Okay, use the intensity of the pixel. So pixels which they're having this, similar, image or a group of pixels with the same value will be segmented together, whilst those with the different values also be segmented different. Okay, battery is going off. Okay, in a minute, you power it. Okay. So segmentation in medical image analysis involves the precise delineation of regions of object within an image. Okay, so you try to draw. So you have an image here, and what you do is that if there are different intensities, okay, you try to draw a line to separate some of them. Okay, separate some of them from it. So we are trying to segment. Okay, and we use it in isolating specific structures or abnormalities within medical image, such as tumors, organs, and blood vessels. All right, so what are the different methods that we use to segment? We have image thresholding, edge-based segmentation, seed grooving, and watershed transformation. Now, all these methods are all traditional methods. All these techniques, all these segmentation techniques are all traditional techniques that we use. If I say traditional, they are hard-coded. They are hard-coded. That means they don't use machine learning or AI. You code it, okay, and it's able to do that for you. Okay, but we are not going to use that. We are going to use machine learning to do segmentation also, or deep learning to do segmentation for us. Okay, so let's look at this. So here, trying to explain. So here, if you look at it, is this image that you see over here. Let me change my pen color. Okay, this one fine. Okay, so this image that you see over here is from this place. Okay, so try to segment that place from the rest. Then this thing that you see over here is from here. Okay, then this thing you see over here is also from what here. All right, so what is doing that is look at the pixel intensity and compare it to the neighbors or the neighborhood, okay, or the adjacent pixels, and try to pull that out. So what it's trying to do is to segment, okay, segment it from other pixels. Yes, Fatima, is there a question? All right, so the image segmentation technique, which is the thresholding, this is obvious. When you have a threshold, it's a value, right? You normally specify that if the pixel is 100, make all of them. If the pixel is 100 and above, make all of them white. If the pixel intensity, let me use the word, if the pixel intensity is 100 and above, make all of them white. If the pixel intensity is 100 and below, make it black. That is thresholding, right? So here, if you look at it, you look at it that, you see where you see the color a little bit, you see how it has deepened it. Okay, so that's thresholding. So try to separate the foreground from the background. Okay, try to separate the foreground from the background using a threshold. Yes, Fatima, is there a question or a mistake? Then also have the edge-based detection. The edge-based detection, try to what? Draw or identify the edges. So it outlines the boundaries for you. And these things is very, very important. Okay. We human beings, for us to be able to know that this is a cat or this is dog, this is whatever, we first look at the edges. The edges first. And deep learning models, they all rely on that. Okay. That is why even people who are blind, anytime they are handling things, they normally use the hand to pass around it. Edges tells you a lot, or edges contains a lot of information. So if you can, get the boundaries, be able to know what the object represents. Okay, right now, if you close your eyes and I hand an object to you, the first thing you want to feel it. But sometimes when you feel it, it's a metal, but what exact thing is it? So what you do is that you try to use your hand around it to get the edges. So once you get the edges, then you can interpret it in your mind that, it's actually a cap, a metallic cap, or this is a metallic bow, or maybe this is that. Yes, Fatima, is there a question? Or is a mistake? Okay, so your hand is still up. Let me let you come in. Fatima Abdul Majid, you can speak. You can speak, please. Okay, Richmond, is it a question? Okay. Oh, if you click things, but I don't know. You don't even know what you guys are. I don't know whether reaching to is a mistake. Sorry, Richmond. No, whether it's a mistake. All right, so let me look for him and I'll mute him. Oh, Richmond, okay. Richmond, speak. Richmond, speak. Okay, then let me proceed. All right, then we also have the seed growing algorithm. Okay, this is like it grows, but that's why the word says seed growing. Okay, so when you look at this, let me change the color. Okay, so let me use a different color instead. Okay, so when you see where there is the white star, yeah, this, okay, when you click, you try to segment, so it grows. That's what I say, seed growing. Okay, so the pixel intensity is over there. Okay, we'll try to use that intensity, try to grow and segment. That will say pixel growing. So it detects a group pixels with similar characteristics. Okay, so as you can see, it can grow. Okay, you can let it grow, but I mean, if it grows too much, you try to go into other areas too as well. Right, is there a question or a mistake? Then also have the watershed transformation. Watershed transformation. All right. Give me a minute, Bright. All right, speak, Bright. You can speak. Use a question, you can go on and speak. All right. So the watershed, normally when you have two regions that try to overlap, okay, the best thing you can do is use the watershed transformation to segment. All right. So you normally use in the brain structure because you have a lot of structures or regions that are trying to overlap or intertwine. So the best option is that you use the watershed transformation to do that. Okay. All right. Now let's talk about feature extraction and representation. Now yesterday I made mention of feature engineering. So now we want to understand what a feature is, right? And I told you that features are also known as measurement, right? Something that you measure. Okay. So a feature is something that can be measured in an image. A color is a simple feature, right? So how will I know sets and also Anthony? I've not seen Anthony physically before, okay, but I know sets. So first, if I know their complexion, that's the first thing we're able to use to distinguish. Okay, that's why I say color is what? It's a feature, it's a simple feature. So even in medical imaging, most of the things that you do depends on color. Okay, because if it's a tumor, the color will be different. If it's a normal cell, the color also will be different. And I mean, that is something you guys do every day when you're looking at different colors. Okay, be able to tell that this is a tumor or this is not tumor, right? So that means you guys, one of the things that you guys will be dealing with a lot is the color feature. Okay. So an object, a lesion or a tumor within an image has a set of measurement features that we can use, okay, to characterize it. So I've explained if the thing is a tumor or a lesion, there are certain features, for example, the color, maybe the size or the shape, or maybe the boundaries. All these things are features that we use to characterize it. Okay, so once you can use that, then these are features that you pay attention to. So in medical imaging, we extract these features, we try to isolate it. So once we can isolate that, we'll be able to say that, because we're able to isolate the features, we know that, okay, this is rough, the edges are not smooth, then this is what a normal tissue. If the edges are smooth, okay, this is a lesion. So these are things that you guys will pay attention to a lot. Okay. Are you okay? All right, so let's proceed. So let's look at this. Okay, so here, we're even doing yes. So here we intend to extract certain things, and with that we'll be able to determine, okay, whatever thing that we are interested in. But let's be quick. How many slides do I have? I think I have wow, I have a lot too. I don't have time. Let me be quick. All right. So let's look at the types of features. We have global features, we also have what? Local features. Okay. So global features, I mean, you are looking at the context or you are looking at the image from afar. So we just want to consider the entire image. All right. So for example, if UDS, okay, if before I enter UDS, the main gate, that is a global feature. But if I'm coming to SAS, is it SAS or SAS building? That is a local feature because here I'm paying attention to what? To something, okay, specific thing, a UDS. So global features, you're just looking at the image. So when the radiologists try to read the scan, first they look at it globally before they now pay attention to it, because the global features also says a lot. For example, if you're all having a round head and you have a square head, that is obvious, right? So your head is square. How can your head be square? So that is going to be dangerous. So first, the global features, we pay attention to it before we now look at what the local features. Okay, I'll be laughing. Okay, so for the local features, you pay attention to specific things, okay? Specific things, okay, in the image, right? So I have an example here. So here I have fruits. So this picture just shows you the global feature, just a collection of what? Of fruit, right? But the local features, I might be interested in a specific kind of fruit. Maybe banana, maybe grapes, maybe tomatoes. Okay, so here I'm interested. So if I want a specific thing in my image, that is a local feature. But if I'm looking at my image in general, okay, and they all have their importance, as I said. If we are all having round head and you're having a square head, immediately I take the scan and I see a square head. Oh no, this is, I mean, abnormality. Okay, you're not supposed to have a square head. Okay, but if your head is round, they would not want to pay attention to certain features that is giving you the maybe the sickness or whatever. Okay, all right. All right, so when we're extracting features, we also have traditional method and also have the deep learning approach. But we are not going to use any traditional method. We are going to use deep learning approaches to extract. Okay, so some of these traditional methods, as you can see over here, the hawk and the sift. Okay, some of these things you can try it, Google, and find out how they are done. And some of these scientists in the centuries, okay, they will really work hard to be able to do some of these things. But now, deep learning has made some of these things possible or simple for us so that we can extract features without struggling. All right. So let's distinguish between feature selection and also feature extraction. So we want to select a feature. All right. So there are two different things. Okay. So where are we? Okay. Yes. All right, so this, okay, did I even define this? Okay. All right, so when we are talking about a feature selection or when you are selecting a feature, okay, what you're actually doing is you are paying attention to specific things. Although feature extraction also, you are paying attention to specific things, but feature selection, they remove something known as redundant features. They remove redundant features. Okay, redundant features, they sometimes cause a lot of issue in our model. Okay, your model, I don't know which example can I be use. Okay, so how will you calculate somebody's body mass index? You need the person's weight and what again? Let me find out body mass index. There's a formula to calculate it. The BMI. Okay. There's a formula, you can combine two things in order to calculate that. So let me have it here now. So in order to calculate somebody's body mass index, which is the BMI, okay, you need one, the weight of the person, then divided by the height. Now I have a table, and this is the table that I have. Okay, the table one, I have the height, which is h. I also have the weight, which is also w. I also have the BMI, which is b. And I'm using it to determine the person, let's say, maybe some sickness. Now these are all features, right? But you will see that they are features. I'm able to extract my features, but I can use the height and the weight to determine what? My body mass index. So in essence, I can select only this whilst removing the height and the weight. That is feature selection. Okay, so when some of the features, they are redundant in vectors. Those of you who join our internship, in vectors, we call it, these vectors, they become linearly dependent. When a vector is linearly dependent, you can't, they will definitely cause a lot of issues, okay? But when the vectors becomes linearly independent, that means you're good to go. You can use it to create more vectors. But when a vector is linearly independent, that is something that we don't want to, okay, use. So in vectors, orthogonal vectors and all these things, they are all independent. That means they have more information for us that we can use. That is feature selection or feature selection. Right. So the next thing is, once you have segmented, the next thing is for us to classify. Classification is when you categorize your medical images into predefined classes or diagnoses. Okay, so this is a tumor, this is on the tumor, this is normal, this is not normal, this is absence of disease, no absence of the soul. You try to put it into groups, okay, or classes. But we have three ways to classify. We have binary classification, multi-class classification, and multi-label classification. What's the difference between the three? All right, so we'll come back here, try to understand. The first one, binary classification, is obvious. Binary, okay? So binary, you try to classify into two categories, okay? Two categories. So normal, abnormal, healthy tissue, disease tissue, benign, malignant, presence, absence. Only two categories. Okay, so whether it is there or it is not. It is there or it is not. All right, so example, as you can see over here, so this is a model somebody built to be able to tell whether the tumor you see there is actually tumor or no tumor. Then we also move on to multi-class. Multi-class is when you want to classify, but it's more than what? Two, okay? It's more than that. Means you have, if I say you want to classify more than two, you have more than two options, okay? You have more than two options. So instead of having tumor or no tumor, this one, you have another one that you add to it. So what happens, and that's a multi-class, okay? So for example, if you want to classify lung into healthy, pneumonia, tuberculosis, and lung cancer, this is what multi-class classification. Then also we want to classify MRI scan into what? No tumor, glioma, meningioma, pituitary. Okay, that is multi-class. So multi-class, you try to design algorithm to analyze medical images, okay, and classify each into one specific category from three or more possible classes. Three or more possible classes. All right. So this is an example, as you can see, multi-class classification. Then the last one is the multi-label classification. Multi-label classification. So here is one single image, but it has different assignment, or it has what? Multiple labels for one single data point. For one single data point. This, let me try to use music to be able to explain this a lot to you, or movies. Okay, when you pick any movie at all, the movie can be what? Or even music. They have the genre, they are, I'm not more into some of these things, but movies, they have their classification. Movies and music, they use multi-label classification a lot. Okay, so one music, okay, you can put it hip hop, high life, whatever, they have ways of classifying it. Okay, the same analogy can also be applied in medical imaging. So here you have an image, a chest X-ray. Okay, so here we assume that the thing is of pneumonia, but we also can talk about another thing, which is what, the pleural effusion and also a collapsed lung. Okay, so here it's just one X-ray image, but it's trying to give you all the possible labels. Okay, all the possible labels that that image is having. That is a multi-label classification. Okay, multi-label classification. So one image, okay, but having what, different labels, multi-label classification. Right. Now let's look at some of the deep learning algorithms that we use in image analysis. Okay. What we will talk about when I come is the convolutional neural network. This is what we are going to talk about. So your project, you guys, your project will be crazy. You have a lot of things to do. So get ready. Right. We're talking about this, but there are other ones that we also use it a lot in image analysis. So for image classification, mostly we use the CNN. And for object detection, in driverless cars, they use YOLO, you only look once, not you only live once. Okay, YOLO, you only look once. Then also have the UNet, it's also another deep learning model architecture that you use for image segmentation. Now I'll show you their architecture. Please do not panic. If I explain them to you, you understand it. Okay, it's not anything, strange. Some of you will panic right now. Okay. All right, so this is the CNN. We'll talk about this Friday, what actually transpire, whatever happens over here. So if you look at it, we have the input, then we have some convolution happening over here. We have pooling, okay, then we have fully connected, we have output. All these things, if I explain it to you, you can be able to build your own model for your own project. Now, if you look at it, we extract the features. So here you see there's feature extraction over here before what we classify. That's why we see deep learning, they can extract features on their own. Other than machine learning. Machine learning, we need to hard engineer the features ourselves, but deep learning, they can extract the features on their own. So then the next one that follows is the YOLO. You only look once. This is quite crazy, but it's not anything crazy. Okay, if you look at the blocks over there, they all have their functions. Okay, but we are not going to do YOLO. But if you have interest, you can look into it and learn much or more about it. And the last one is the units. The reason I call it unit is look at the shape. It's like U, right? That's a unit. Now this mostly is for encoding and decoding. Okay, so we encode, then we decode, as you can see. Now all these things, it's not anything big. If we explain it, or if I explain it to you and you get a concept, you're able to see what is actually happening, the flow of your data. Okay, as the data passes through, what actually happens to it. All right, I'll explain all these things usually on Friday. Is it Friday? Yeah, tomorrow. You've forgotten, tomorrow is Friday. Friday, so make sure you don't miss Friday's lecture if you really want to pick up your machine learning journey seriously. All right. So at this juncture, I will say thank you guys. Any question for me? Any question for me? Okay, so Brahma Abdul Mubarak. Is there a question? Okay, no, just raise your hand. All right.
Bega ni no kwa man. Shedi na no kwa man. Wanda mama ndro. Ya kan kwa. Kwa